Assalamu alaikum wa rahmatullahi wa barakatuh. So finally we're at the fifth part. I'm going to try to, do two questions for this kind of question type, right? And remember one thing, this type of question, the one that I'm about to talk to you all about, it can arrive with the at most keyword and it can also arrive with a at least keyword, like at most and at least, with both of these keywords. Either one of these, that's what I mean, right? So let's say they want us to find the, you know what, I'm not going to keep on talking about what we learned in the previous lesson. Why? Because these are pretty short, so just watch them all in one go. For the second part, for the D part, I'm going to say find the probability that she obtains a four. Sorry, that she obtains a heads at most 10 times. At most means less than or equal to 10, right? So this would be x is less than or equal to 10, right? Now, what do you think you have to do in here? Do you think, do you really think, you know what I'm about to show you is actually a legit method of doing it. You can do it this way. Px is equal to 0, plus px is equal to 1, plus px is equal to 2, right? And you're just going to keep on going until you finally reach px is equal to 10, right? My pen just stopped working. I was actually kind of scared because I'm recording right now, and if your pen just runs out of battery, you're like, man, the entire momentum has been destroyed. But no, that's not the case. So you go. Do you think you would have sorry? Do you think you would have to go all the way up from 0 to 10? I mean, that would be quite a lot of work. This would be cumbersome, right? And that would be extremely tedious and boring and monotonous. So why would you do that? And again, it's just a wastage of time. So, and these kinds of questions are at max three marks or 2 marks, right? So why would you be spending so much time and so much mental energy and effort onto this? Now let me show you a better method, a way better method. What is the total values for R, the number of successes? I was calling it tries, my bad. I'm sorry. So look, I'm going to write all of them. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 3, 2, 1, and 0, right? So what do we need? Out of all of these, what do we actually need? We need at most 10 of them, which means we either have, look, this is what we need. This is the probability that we need to find. Now, instead of finding all of this, or you know what? Let's just make it not 10. Let's just make it 13. Let's just make it 13. This is 13 and this is 13. So what we actually need is this box, right? So do you really think we would go all the way down from 0 to all the way up to 13? That's just not right. You know, this is what we need, this box. So what should we do? You know what? Remember one thing, the probability for like all of the values for R is going to be 1. So if I also add, plus 14 and plus 15, then my answer is going to be 1. Why? Because the total probability is always going to be 1. So in this case, we know that the total probability is 1. So instead of having to find all the way from 0 to 13 manually, instead of finding all of these manually, why not take 1 and subtract from it px is equal to 15 plus px is equal to 14. Why not just do that? Why can't we do this? Wouldn't this be easier? Wouldn't this be better? This saves time, right? This is exactly what we do. So, and how do you know when do you have to do this kind of question? We're going to do it twice, right? Once with the at most one and once with an at least keyword, right? Now look, once you see that the number of these things over here is becoming way too big and it's just going to be, killing your time, it's way better to just, grab the smaller chunk of data and subtract it from a 1. So this entire thing, we can find the answer doing this. 13 is equal to 1 minus px is equal to 14 and px is equal to 15. This is how you do it. And the rest of it, you know how to do it. 1 minus, that would be um 15c 14, 0.67, 14, 0.33, 15 minus 14, right? Plus 15c 15, right? 0.67 is 15 and 0.33 is 0. Why? Because 15 minus 15 is going to be 0. And this is it. This is literally it. You know what? Just so that I can make it look better, I would just take this to the other side. Now it looks better. This is how you solve it, and the answer is going to be so this block. Oh, the pair is being called. Okay, so now look, this is going to be your answer, right? So first you calculate this, you add the probability for 14 and 15, and then you just subtract it from a1. That's it. Now I can write it another way as well, right? And I think I should. You know what? Let's do another part of this. If this is D, then let's do an E1 as well, right? I'm not going to say, you know what? Instead of writing this, I'm just going to do this. Find the probability that she obtains a head at least, at least 2 times. At least 2 times. The reason why I made these lines over here is just to denote that because I've been, repeating the same, initial statement for these. It's better to just not do that again. I mean, these lines are just, find the probability that she obtains her heads at least 2 times, right? Now look, again, I'm going to write this entire thing, right? 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Now, what does at least mean again? Greater than or equal to. So what they're asking us for is x is greater than or equal to 2. And now look, this is going to be px is equal to 2 plus px is equal to 3 all the way up to px is equal to 15, right? Now again, this is cumbersome and this is tedious. Why would you do this entire thing? What do you actually need? You need this box, right? You need this box. So all that you've got to do, you need to do this. 1 minus px is equal to 0 plus px is equal to 1. This is all that you've got to do, right? So instead of having to do this box manually, this is what we need, right? Instead of having to do this entire box manually, why not just do this and subtract it from 1? That would be better, right? So you just write 1 minus and then you find the individual probabilities for 0 and 1. You add them up and then you subtract it from 1. Why? Because this is going to give you this other part. So, the main concept that we're trying to apply in here, or the main technique that we're trying to apply in here is you take the smaller chunk of data, you take the smaller chunk of data You try to find that and then you subtract it from 1 in order to find the greater chunk of data. Pardon me. And then you can easily find the greater chunk of the data, right? Now, I don't really think I need to do it again, but I still would. That would be 15C0, right? 0.670 and 0.33 would be 15 minus 0 plus 15C1, 0.671 and 0.33 would be 15 minus 1. That would be 14, right? And this is how you're going to get yourself the answer, right? So this was for the fifth part and the second last part. Now we're going to do the final part. Inshallah ta'ala, in the next lecture, it would be part 6. And we're going to use logs to find n. So far in all of these questions, the n, was given to you. This time you are going to find it yourself. Okay? I'm going to see you in the next lecture. Assalamu alaikum wa rahmatullahi wa barakatuh.